looking at a few things I saw in the tests that I think you'd be better off if you did a little bit differently. Okay, for example, we have some object here. I think I said something about an aardvark. Not a very good looking aardvark, obviously. But we had a diagram that looked very much like this. 0.02 kilograms normal force, mu k times normal force, and 0.8 meters per second on a single diagram with the arrows distributed in a manner similar to this. Now there are several things wrong with this, but the idea is pretty good. Okay, first of all, 0.02 kilograms is not of the same units as the normal force or the frictional force, which is the mu k times normal force. And the mu k times the normal force is not bigger than the normal force, because mu k is, as is typically the case, somewhat considerably less usually than 1. So that this vector would be quite a bit shorter than the normal force vector. 0.02 kilograms isn't even a force. 0.02 kilograms is a mass. And the intent, I believe, was that this should represent a force. Should not have been labeled 0.2 kilograms. And then 0.8 meters per second, you know, if you just look at the arrows, it looks like that ought to be another force. And that's off to the side somewhere. It's ballpark okay, but everything would be a lot clearer. And the main purpose, of course, because this is on a test, is for it to be clear to you when you're thinking through it, so you don't make a tragic error, crash your spacecraft into Mars and so forth. When you do a free body diagram for a point-like mass, for a particle, for something that doesn't rotate, in other words, you represent that object by a dot. And then you don't have the normal force. Yeah, I mean, it's okay when you're doing a kind of a picture to get your mind around the situation to do things like this, but you need to consolidate it into something like this. And you probably don't want a force pushing up on that dot from below. You generally want the initial point of your vector to be at the dot and the terminal point to be away from the dot. And that's just really a matter of bookkeeping. It's a way of looking at it that results in minimal confusion. Okay, so we would put our normal force here. Of course, our normal force is a vector. And then we have 2 Newton vector here. We could write that as 2 newtons, negative 2 newtons times j if we like. But indicating that it has a magnitude of 2 newtons is okay. And then we have our frictional force, which is going to be shorter than the normal force because the coefficient of friction, of kinetic friction especially, is generally considerably less than 1, so that this vector is considerably shorter than this. And we wouldn't have the 0.8 meters per second in that free body diagram for the forces. We'd maybe have it over here. And we could even put a dot on it, because now we understand clearly that's not a force, and we probably ought to say V naught equals 8 meters per second, or something like that, to indicate clearly that this is a velocity and not a force. So this is a much neater way of looking at it, and much less likely to be misinterpreted, a much better representation of what's really going on.